Assalamualaikum and good morning. Thank you for spending your time to hear my presentation. First of all, I will present about thermal and flexural properties of silane-treated bamboo fiber reinforced PLA HDPE composites for electrical insulation. Next is I want to show my supervisor, which is Dr. Mazatul Ziha binti Ahmad, and me, Siti Aishah Liyana binti Roslee. Sorry because I forgot to introduce myself. My name is Siti Aishah Liyana binti Roslee. Okay, next, for the part introduction, I will cover research background, problem statement, and objective. Firstly, about study background, which is research background. Okay, first of all, natural fiber, such as bamboo fiber, kena fiber, jute fiber, hemp fiber, face limitation in polymers composite due to hydrophilic properties and high moisture absorption. So to overcome this limitation, we treat by alkaline treatment and silane treatment to improve the mechanical properties of natural fiber. For the part silane treatment and alkaline treatment, I will explain more detail in methodology part. Okay, next is about PLA, which is polylactic acid. It have poor heat resistance due to slow crystallization and low crystallinity. And also we have HDPE, which is high density polyethylene. It have the characteristic of HDPE is brittle and have low melting point. So to increase the polymer blends to increase the polymer blends properties, we will blend PLA with HDPE and also with fiber to improve the thermal stability, surface modification, and also flexural properties. Okay, next is about problem statement. Okay, in this study, I will use bamboo as my sample to test the polymer blends. So bamboo is lightweight, high strength and modulus, good stiffness and biodegradability. Since this bamboo not treated with pre-treatment, so it have poor fiber polymer matrix interfacial interaction because it have presence of hydroxyl group. So to improve the interfacial interaction, we will treat the bamboo fiber and blend with PLA HDPE to improve the heat resistance and also flexural strength. Okay, next for this study, my objective is to characterize the effect of silane treatment on bamboo fiber. Secondly, to investigate the thermal properties of silane treated bamboo fiber reinforced PLA HDPE composite. And thirdly, to determine the flexural properties of silane treated bamboo fiber reinforced PLA HDPE composites. Okay, so we will move to the literature review. In this part, I will explain more detail about polymer blends, about bamboo fiber, about their physical properties and chemical properties, and also about PLA HDPE blends. Okay, firstly, physical properties of bamboo fiber and chemical properties of bamboo fiber. Physical properties of bamboo fiber is low density, lightweight, good moisture absorption, moderate thermal conductivity, and also good flexibility. Meanwhile, for chemical properties of bamboo fiber is cellulose composition and lightning content, which is these two content is very crucial in bamboo fiber, and also have important roles when we blend with polymer blends. So next is about polymer blends and PLA HDPE blends. Okay, first, polymer blends have three types, which is immiscible blends, compatible blends, and miscible blends. Okay, firstly, immiscible blends. Immiscible blends are polymers that do not mix at a molecular level and leading to phase separation. Secondly, compatible blend, which is the degree of miscibility between the polymers to allow partial mixing at the molecular level. And then thirdly is miscible blend, which is this blend is fully soluble in each other at a molecular level and form a single phase material. So by blending PLA and HDPE, this will result composite. This will make composite improve the stiffness, toughness, impact resistance, and processability compared to other individuality polymers. Next is about bamboo fiber reinforced PLA HDPE composite. Okay, just like I said just now, PLA have poor toughness and low elongation at break. Meanwhile, HDPE have good mechanical properties, including higher elongation compared to PLA. So when we combine, for the bamboo fiber also have good mechanical properties, but it have poor interfacial adhesion. So when we will, after we treat the bamboo fiber, it will improve the mechanical properties of bamboo fiber. And then if we mix bamboo fiber with PLA and HDPE blends, it will improve strength, durability, and sustainability of the composite. Okay, next is about thermal properties of bamboo fiber reinforced PLA HDPE composite. Okay, the thermal degradation of fiber leads to poor mechanical performance. So, by adding bamboo cellulose fiber to PLA, it will increase the thermal properties of the composite, and also the crystallization behavior and thermal stability of polymer composite also increase. Okay, so next is about flexural properties of bamboo fiber reinforced PLA HDPE composite. Okay, flexural strength of silane-treated bamboo fiber is higher. So when we adding bamboo fiber with PLA and HDPE blends, it will improve the resistance of the bending, the flexural bending, and it will lead to increase the stiffness. Because why this can happen? Because bamboo fiber act as reinforcement, which is it reduce the tendency for cracks and deformation to propagate. Okay, so next is about natural fiber reinforced polymer composite for electrical insulation. In this study, besides we test the bamboo fiber with the polymer blends, we also want to know if this composite are suitable for electrical insulation. So, based on what I get from the research, okay, natural fiber have low electrical conductivity. So, to increase the electrical insulation performance ni, we will treat this natural fiber to improve the fiber matrix adhesion and enhance the electrical insulation performance. So for the choice of polymer, usually researchers will use epoxy polymer because it have good compatibility with natural fibers to ensure a strong interface and maintain the electrical insulation properties of the composite. So after natural fiber and this polymer combine or blend, it will enhance the electrical insulation performance, which is it good for the electrical insulation properties. So other than that, to increase the electrical conductivity, or to increase the electrical resistance, we decrease the moisture absorption, so that it can work properly for the electrical insulation. And next is about methodology. Okay. First of all, we will prepare bamboo fiber, which is we will get from bamboo fiber from the bamboo fiber company to from the bamboo fiber company, and then we will use that bamboo fiber to do this research. Okay, first, that bamboo fiber we will treat with alkaline treatment and silane treatment. Alkaline treatment, we use NaOH, which is sodium hydroxide solution, to increase the to remove the hydroxyl group in the bamboo fiber. So after we treat with alkaline treatment, we will treat with silane treatment for 24 hours and heated at 80 degrees Celsius, because we want to increase the interfacial adhesion of the bamboo fiber, so that it can blend well with polymer blends. Okay, after that is about fabrication of composite. Okay, fabrication of composite means we will prepare the polymer blends, which is for the moisture content of PLA HDPE, we will use 5%, 6%, 7%, 7%, and 9% to test the mechanical properties of the polymer blends and natural fiber, which is bamboo fiber. After we green in internal mixer, and we will compress in compression molding to make a dumbbell shape, according to the standard of ASTM. So for my study, I will test for flexural strength, so I will use ASTM D790. Okay, after that, after we prepare the bamboo fiber and PLA HDPE blends, we will test by using FTIR and SEM to determine the characterization of the bamboo fiber, and also we will use TGA and DSC to test the thermal properties of the bamboo fiber reinforced PLA HDPE composites. And lastly, we will use 3-point bending flexural testing to know the flexural strength and flexural modulus of the bamboo fiber reinforced PLA HDPE composite. So next, for the expected result, for FTIR, we use to analyze and characterize bamboo fiber powder, which is to know the presence of the functional groups, and also to improve the interfacial bonding between the bamboo fiber powder and the PLA HDPE matrix. Next, the result of SEM. We use SEM to know the cleanness and the smoothness of the fiber surface, whether it increase or decrease after pre-treatment. So we will compare the untreated bamboo fiber surface and also treated bamboo fiber surface. So the surface of the untreated fiber is covered by a superficial layer of impurities, and then the cleanness and the smoothness of the fiber surface will increases after the pre-treatment. So as a result, bonding reaction and interlocking adhesion which increase the adhesion of the fiber matrix. Okay, next for the thermal properties, we use TGA and DSC. Firstly, TGA used to examine the degradation temperature of the composites. Degradation temperature of the silane treated bamboo fiber powder reinforced by HDPE composite will be higher, which is at the range of 364 degrees Celsius and 499 degrees Celsius. And for this DSC, we used to investigate the melting temperature and the degree of crystallinity. So we expected the melting temperature is 153 degrees Celsius and the degree of crystallinity is around 12%. Last but not least is about 3 bending point flexural testing. We test the bamboo fiber reinforced HDPE composite to know the flexural strength and flexural modulus of the composite, whether it increase or decrease. We expected that we will get flexural strength and flexural modulus increases by increase the moisture content. So higher flexural strength are greater loads without fracturing. Higher flexural modulus will enhance the material's ability to resist the deformation under bending stress. For the conclusion, I will conclude that this study expect firstly higher strength with silane treated bamboo fiber and an increasing strength with higher fiber content. And secondly, we expect that we can improve the thermal stability after silane treatment. And lastly, we expect that we can improve the flexural strength and modulus after bamboo fiber blend with PLA HDPE. So that's all from me. I hope you understand what I present, and so that's all from me. Thank you.